Hello, and thank you for joining me. I'm doing a walkthrough for a GCSE paper today. I'm going to be looking at the AQA past papers, and the paper in particular that we're going to be doing today is back from June 2019, and this is a paper 3H, so the higher tier. Attached to the description of this video, you will find a link to a Google Drive that will take you to a copy of this paper if you've not already got one. And I would strongly recommend you either do the paper before watching the video or do it alongside the video just to get the most out of it. I would also recommend some music on in the background. While I'm recording these videos, I tend to have some music on, an ear pod in the background. I'd recommend that. It just makes it a bit easier to get through. And if you find this video useful, please do subscribe if you like. Right, before I get into the paper, I'm just going to bring up the exam analysis. So this is a Q&A for the paper, question level analysis, and it goes into quite a bit of detail that's quite useful for us to consider before we start the paper. The first part is the mean mark achieved by grade. So this gives you a breakdown of kind of the grade boundaries for this paper. And it's an approximation because it's done over the 3 papers, obviously. So that's the breakdown of what kind of grade you need. So how many marks you need for the grades. The other thing that I've included on this is the question facilitated by grade, because I find that quite a useful tool. It kind of tells you how difficult the questions were. Like, for example, a good one to pick out would probably be this one here. So on average, even the grade 9 students only scored 60% on this question. And that is quite middle of the paper. That's sector area comparison. So that's just quite useful to kind of get a feeling for the paper. Typically speaking, the questions are ranged roughly by difficulty, but there are a couple of outliers which are quite useful to just mention before we start the video. Okay. So for today's paper, the emulator I'm going to be using is an FX 570 emulator. That's just it's a nice emulator that I've got rather than some of the other web-based ones. If you've got a different calculator, it's no big deal. I'll talk about any deep functions I use on that as and when it appears. Okay, let's start off then. Question 1. Work out 1.5 as a fraction of 60 pence. Circle your answer. Okay, so we've got a mixture of units here. I'm going to convert them all into pence. So let's turn it on first of all. So it's going to be 60 out of 150. And then we can use our calculator to simplify that down, although I'm sure you are all more than capable of simplifying that down without a calculator. But as we're on a paper 3, it makes sense to just use it wherever we can. So 60 over 150. I think it's going to cancel down by 30s. Yeah, 2 over 5. So 2 over 5 is our answer. Question 2. For a biased dice, the probability of getting a 6 is 3 out of 5. Circle the probability of 2 6s when the dice is rolled twice. So that's going to be 3 over 5 squared, so it's going to be 9 over 25. So we're going for that one. Okay, question 3. Circle the lowest common multiple of 5, 15, and 25. So the lowest common multiple is the lowest number in all of their times table. So to be fair, the 5 is irrelevant because the 5 is a factor of 15 and 25. So really, we just want the lowest common factor, or lowest common multiple, sorry, of 15 and 25. Well, 15 is 3 times 5, and then 25 is 5 times 5. So the lowest common multiple is going to be 3 times 5 times 5. So that's going to be 7. Okay, question 4. Circle the 2 roots of x minus 5 and x plus 3. So we want to be whatever makes these brackets 0. So to make this bracket 0, x would need to be equal to 5. To make this bracket 0, x would need to be equal to minus 3. So there we go. Question 5. On the grid, draw an enlargement of the triangle with a scale factor of a half. So we're not given a point of enlargement, so we just need to make this half the size. So wherever you want to start drawing it, really. Instead of being 4 across, it's only going to be 2 across. Instead of being 2, 4, 6 up, it's only going to be 3 up. So that's going to be my enlargement drawn anywhere. You're actually going to draw it with a ruler. Right, question 6. To the nearest pound, John has £9.50, and to the nearest 50p, Ellie has £6.50. Work out the maximum possible amount of money. So if we look at John first of all, so to the nearest pound, the smallest amount he could have would be £8.50, and the largest amount would be £9.50. I'm going to put for now. Technically, you couldn't have £9.50 though. And then for Ellie, we'll do a similar thing. So the smallest amount Ellie could have would be £6.25. The largest amount would be £6.75. So technically speaking, I'm going to be adding these two together, but they can't quite have that. So the maximum money that John could have would be £9.49, and the maximum amount that Ellie could have would be £6.74. So if we add those two numbers together, so the maximum amount would be £16.23. Okay, question 7. Two solids J and K have the same density. Complete the table, including units in your answer. Right, so we're going to be using J to work out the density. K is going to have the same density, and then we're going to use that then to work out the volume. So if we look at J first of all, so density is equal to mass divided by volume. That's going to be 48 divided by 8, which is going to be 6. So 6, and the unit would be grams per centimetre cubed. I know that because I'm dividing a value of grams by a value of centimetres cubed. So K has got the same density, metre cubed. So for K, the volume is going to be equal to mass divided by density, which would be 78.8 divided by 6. Which would give us 13 centimeters cubed. Right, rearrange y is equal to 3x minus 2 to make x the subject. Circle your answer. Right, so I'm going to start by adding 2 to both sides. So y plus 2 would be equal to 3x, then divide by 3. So y plus 2, divided by 3 is equal to x. So which one of those does that one? That one. Okay, question 9. Towns P, Q, and R are connected by roads. PR is 10 kilometers longer than PQ. QR is twice as long as PR. Total length of the 3 roads is 170 kilometers. Work out the length of PQ. Right, so my 3 roads then are PR, PQ, and QR. Right, I need to bring in a bit of algebra for one of the values and then use a comparison to that. Because PR is used twice, I'm going to call that one X. And then PR is 10 kilometers longer than PQ, so PQ is 10 less, so X minus 10. And then QR is twice as long as PR, so that would be 2X. And their total is 170. So what I'm going to do then is add these 3 values together. That would be X plus 2X, that would be 4X. Minus 10 is equal to 170. So I'm then going to add 10 on both sides, so 4x is equal to 180. So x is equal to 45. Right, however, it asks for PQ, and I've worked out PR. So PQ is 10 less, so PQ would be 35. Right, question 10. Mia wants to borrow £6,000 and repay it with interest after 2 years. She sees two loan offers. Offer 1, compound interest at 3% per year. Offer 2, compound interest, first year 1%, second year 5%. Mia says, I will pay back the same amount because the average of 1 and 5 is 3. Is she correct? You must show you're working. Because it implies working. Well, straight away, no, because that's not how compound interest works. You don't take the average of the 2 years. And her statement isn't, I will pay back the same amount. The statement is because. So you could argue that, but as it says, show you're working, I'm going to show my working. So offer 1. And actually, the £6,000 is irrelevant here, really. I'm just going to call it X for now. So X times by the interest would be 1.03 squared. And for offer 2, again, the initial amount doesn't really affect this question. So for the first year, 1% would be 1.01. For the second year would be 1.05. So that means my multiplier would be, for offer 1, my total multiplier would be 1.03 squared, which is 1.0609. And for offer 2, it would be a multiplier of 1.01 times by 1.05, which would be 1.0605. So we've got a difference here. So no, offer 2 would be better. And again, we don't actually need to work out the value. Just working out the multiplier is absolutely fine. Right, question 11. Here are two sets of numbers, A and B. The mean of set A to the mean of set B is 3 to 8. Work out the value of X. Right. So I'm going to, because of dealing with the means, this would be kind of divide by 4. This would be divide by 5. So I'm going to manipulate that first of all, because that's just going to be a bit of a pain later on in the question. So what I'm going to say is, if the mean of A to the mean of B is 3 to 8, then the total of A, not 8, total of A to the total of B has to be, the mean's been divided by 4. If I times by 4, 12 to the mean of B, 40. I might want to simplify down. They've both got 2 in common. 6 to 20. They've both got 4 in common, so that would be 3 to 10. Right, so the total then of A is 200 plus 160 plus 104 plus 100. Double check that I've typed that in right. So that would be 564 to 270 plus 400 plus 483 plus 300. So that'd be, I feel like I've typed that in wrong. It's 270, 400, 483 and 300. So 1453 plus X. Okay, so what do I need to times 3 by to get 564? I need to times by 188. And this value would be, so 564 to times this by 188, 1880. So this total needs to be equal. So if I do x is going to be equal to 1880 minus 143 or 1453. Right, so 1880 minus 1453 gives me 427. That's not the only way you could do it. You could have done it based on the means without just in this ratio here. That would be fine. You'd just be ending up with more of a complicated. You'd be working out x over 5, but that's absolutely fine. Right, question 12. A straight line has a gradient of 4 so that, and passes through the point. Work out the equation of the line, giving your answer in the form. So gradient of 4 means m is equal to 4. So that gives us y is going to be equal to 4x plus c. And we're going to use the coordinate 5, 23 to work out the value of c. So 23 is equal to 4 times 5 plus c. So that's going to be 20, so c is going to be equal to 3, meaning the equation of the line would be y is equal to 4x plus 3. Right, question 13. Vectors a and b are drawn on a grid. Write b in terms of a. So let's just look at this. This is 3, 2. This is in the opposite direction. So that is 2, 4, 6. So that is minus 6 minus 4. So in effect then b is equal to minus 2a. Right, question 13. Vectors c and d are drawn on the grid, c and d. On the grid above, draw a vector representing c minus d. Okay. Probably the most simple way of doing this then is if we pick a start point, vector c is 2 across 1 across. And then top to tail, I've drawn that badly. Let me start here. So that would be c, and then minus d. I've done it again. So I want to go in the opposite direction. So where I started was absolutely fine. I judged the arrow. So that would be vector c, and then followed by d, which is 2, 4, 6, 7. 2, 2, 4, 6, 7. So 2, 4, 6, 7. So that's going to be c minus d. On the grid above, draw a vector representing c minus d. So that would be my c minus d. If I want to do it in terms of show it properly, so c is minus 1, 2, and then minus d. D is just 7, 0. So the result should be minus 8, 2. And let's just check that that works. 2, 4, 6, 8. Yeah, that works. Right, question 14. For class X, the number of boys, the number of girls is 7 to 8. For class Y, the number of boys to the number of girls is 3 to 4. Which of the statements must be true? Class X has more boys than class Y. X has twice as many girls as class Y. class X has a greater proportion of boys than class Y. Okay, so I don't think we can say numbers because, for example, this class could just have 14 and this could have a multiple of 7, so could have 70. Class X has a greater proportion of boys than class Y. So the proportion of boys is 7/15 here. The proportion of boys here is going to be 3 out of 7. So 7 divided by 15 is equal to, as a decimal, 0.46 reoccurring. And then for the other one, 3 divided by 7 equals 0.428 dot, dot, dot. So we have a greater proportion of boys in class X than Y. Class X has the same proportion. So that's going to be our statement. Okay, fully simplify. We can cancel a C here and a C here. We can cancel an A here to make that 2, and we can cancel 2 here to make that 3. So we're left with A squared over DB cubed. So I'm going to leave it as A squared over DB cubed. Could write it other ways. Typical way would be A squared D to the -1, B to the -3. That would be arguably a better version. But I'm going to go for that as my answer. So the range of samples then. Sorry about that pause. I thought I'd pause the video. Probably worried that I didn't unpause for this one. So if I didn't unpause for this one, I'll just quickly talk you through it. I've got a feeling that I might not have. So what I've said is sector sizes was my first key thing. Sector size is going to be x over 360 times by pi r squared for the first one. That would be 1.5 the radius squared. 1.5 squared. 1.5 is 3 over 2. So square that becomes 9 over 4, and that cancels to x over 160. When I did the same for the second one, it simplified to x over 180, and then that told me that sector A was the smaller, the bigger. Right, back to this question. So for this one, I need the range of values of faulty kettles. So I don't need a lot of this. I need the smallest value here. The smallest value here is this one, and then the largest value here is this one. So these are, each sample has a size of 200. So in effect, I want the largest take away the smallest, which would be 200 times by 0.035 minus the smallest one, which would be 200 times by 0.01. So in effect, I can say that that's going to be 200 times by 0.035 minus 0.01, which is going to be 200 times by 0.025. So 5. Okay, question 15. Sorry, question 18. Is that right? 14 jumps to 18, so we've got a bit of an issue here. Okay, I thought I expected a big issue. It's not a big issue. The questions are numbered wrongly. 14, 15, and then it jumps to 13 for some reason, so that's actually 16. That's actually 17. Is 18. So apologies if the copy that you've got has got those question numbers wrong. So right in the form where A, B, and C are integers. Okay, so if we multiply out this bracket first of all, that would give us 3x squared minus 9x is equal to 4. If we then take everything over to the one side, that would give us 3x squared minus 9x minus 4 is equal to 0. So there we go. 3x squared minus 9x minus 4 is equal to 0. Okay, solve, give your answer to 2 decimal places. So that implies that we are doing it using the formula, which is absolutely fine. Could complete the square, but it's not particularly what I want to complete the square. Technically speaking, AQA course, completing the square with non-monic, well, with that x squared not being 1, isn't really a format that we use. So I will use the formula to do normally. So A is equal to 3, B is equal to minus 9, C is equal to minus 4. And then, so x is going to be equal to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Right, so that's going to be 9 plus or minus the square root of 81 minus 4 times a, 12. 12 times 4 is 48, so that's plus 48, all divided by 6. Right, I'm going to do my negative version first of all. I should put it as a fraction to start with. Let's start that again. I will put that. So it's going to be 9 plus or minus, mistype there. One, 2, 9 over. So my first value then is going to be minus 0.39, 2 decimal places, and then I'll replay, change that for a plus. .3. Okay, question 19. Here is some information about the times people took to complete the survey: fastest, slowest, median, lower quartile, interquartile range. Ben draws a box plot to show this information. Write down 2 criticisms. So let's just check his value. So fastest time 3 minutes. Has he entered that right? Yep, that one's right. Slowest time 18 minutes. 15. He's entered that one right as well. Median of 11. He's not entered that right. Lower quartile 7. 1. He's entered that right. In quartile range 8 minutes. So difference between 7. Quartile range of 8 would take us to 15. 2 criticisms then. So median is plotted 1.5. And then the second criticism is interquartile range. It's plotted 16 instead 15. Okay, question 20. D is directly proportional to the square of V. When D is 6, V is 20. Work out the equation connecting D and V. Okay, so first of all, D is directly proportional to the square of V. So D is going to be equal to K times V squared. Then we need to use this to work out the value for K. So K is going to be equal to D divided by V squared, which is going to be equal to 6 divided by 20 squared. So 6 divided by 20 squared is 3 over 200. So the direct equation is going to be D is equal to 3V squared over 200. I work out the value of D when V is 30. So D is going to be equal to 3 times 30 squared divided by 200. So I just need to multiply my answer by 30 squared. 27 over 2. We'll give it as decimal though. 27 over 2, which is going to be 13.5. Okay, question 21. Hanif makes green paint by mixing blue paint and yellow paint in the ratio of blue to green 7:3. He buys paint in 50-litre containers, each costing, he buys blue paint. He buys yellow paint in blah, blah, blah. He wants to sell the green paint in 5-litre tins and make a 40% profit on each tin. How much should he sell each tin for? Okay, so we've got to assume that he can only buy it in that ratio. So let's look blue to yellow. Right, we've got 7 to 30. Right, so we want in effect. Right, this question, just thinking about it. Right, so strategizing before we do this. So we need to work out the cost of making the green paint. We're given this quite a difficult one, not difficult, but we could work out exactly how much, assuming that we can only buy 50 litres and 20 litres. We could work out a huge value for the minimum amount, but realistically, it's not going to affect anything. So the price per litre is really the only key factor here. So the price per litre of the blue paint, sorry, is going to be 225 divided by 50. So 225 divided by 50. So that's going to be 4.5 price per litre. And then price per litre of the yellow paint is going to be 80 divided by 20. It's going to be 4. So the price for, let's just assume that we're going to make 10 litres. So the price for making 10 litres, obviously we can't make 10 litres, but whatever value we end up being the lowest common multiple that we can make is irrelevant. We can still look at the price per litre for 10. So 4.5 times by 7 is going to give us 31.5. and then the price per litre of the yellow paint would be 12. So to make 10 litres of green, we would need to spend a total of 31.5 plus 12. So we need to spend a total of £43.5 for 10 litres. For 5 litres, which is what we're going to be selling it for, 5 litres, the price of manufacturing for 5 litres is going to be divided by 2, £21.75. So that's how much, that's the cheapest that he can make 5 litres. If he wants to make a 40% profit on each tin, we need to do £21.75 times by 1.4. Which is giving us a total of £30.45. Right, 40% profit. Okay, question 22. The universal set is 29 students in a class. C, students who own a cat. D, students who own a dog. A student is chosen at random. A student is chosen at random. Circle the probability that the student owns a cat or a dog, but not both. So cat or a dog, but not both, is going to be 12 out of 29. Right, part B, a student owns a dog, so we're going from a different denominator. Circle the probability that the student also owns a cat, so it's going to be 8 out of the number that own dogs, which is 8 plus 7, so it's 8 out of 15. Here is a sketch of the curve y is equal to 2 to the power x. On the axis above, sketch the curve of y is equal to 3 to the power x. Okay, so for this curve, for any curve like this, it will pass through that point. Then if you think about it, it will kind of have this tendency here. What it will do is it will be steeper here and it will be less here. So you're in effect drawing a curve less than the curve here and then greater than the curve here. And that's all we really need. Okay. Question 24. The length of diagonal of a cube is 20 centimeters. The angle made with the base is 24. The area of the base is 150. Work out the volume of the cube. Okay, so we just need the vertical height then. The diagonal is 20. And we want this height here. If I just kind of redraw that here, we've got a right angle here, we've got a diagonal of 20 here, and we've got an angle of 24 here. So we want to work out the height. This is the opposite and this is the hypotenuse. So the trig ratio that involves O and H is the sine ratio. So the sine is equal to the opposite over the hypotenuse. We want the hypotenuse though, so the hypotenuse is going to be equal to the opposite times by sine of the angle. So the height is going to be equal to, no, we messed up slightly. We want to work out the opposite. So the opposite, calling them both H is throwing me out slightly. The opposite is going to be equal to times by H. So H, the height that we're after, is going to be equal to 20 sine 24. And I'm not going to go to my calculator just yet. The volume is going to be equal to the area of the base, so 150 times by H. So that's going to be equal to, I'm just going to type it in there, 150 times by 20 sine 24. So the volume is going to be 1220.2099 ... So I haven't rounded. Okay, so being realistic about this, my degree of accuracy, so we've got maximum of 2 significant figures, 2 significant figures, maximum of 3 significant figures. So I'm going to go 4 significant figures. So I'm just going to go 1220. Right, question 25. Square, we've got the coordinates of the square. Right, a single transformation a single transformation of A, B, C, D is such that B is mapped onto D. B is mapped onto D. So that's the new position of B. D is mapped onto B. A and C are invariant points, so they don't move. I describe fully the single transformation, so that's got to be a reflection in that line. So a reflection in the line. Let's right line a little bit better, in the line. And that line would be y is equal to 1. Hey, 25, a different single transformation of A, B, C is such that B is mapped onto D, D is mapped onto B, and only the only invariant point is 0, 1. 0, 1. Okay. Let's change pen color for this one. So let's look at that again. So that's still mapped, that's still mapped. B to D, D to... Okay. So that's going to be a reflection. Sorry, a rotation. Rotation of 180 degrees. About 0, 1. 26. Given that g of x is 16 minus x and h of x is x cubed, solve g of h of x of 24. Okay. So let's do this in terms of algebra. Ignore the 24 for now. So we're putting that into this equation. So g of h of x is going to be equal to, so 16 minus x cubed. That's equal to 24. So 24 is equal to 16 minus x cubed. So rearranging that, then that gives us x cubed is equal to minus 8. So x is going to be equal to 2. Sorry, minus 2. Okay, 27. In this equation, all lengths are in centimeters. A is a point on a circle of center O. B is a point on a different circle of center O. The length of A to B is equal to 20. Okay, the equation of the larger circle is the radius of the smaller circle to the radius of the larger circle is 4 to 5. Work out the size of the angle AOB. So we want this angle here. Okay, so if we look at the equation of the larger circle, I'm just going to rewrite that as x squared plus y squared is equal to 12 squared. So the radius of the smaller circle, so let's call it a radius of A to radius of B, has to be in the ratio 4 to 5. Okay. But the actual radius of B is 12. That's not a very nice number. So 12 divided by 5 is going to be equal to 2.4 over 5. So the radius of B is going to be equal to 48 over 5. I think 9 over 6 is the easier one to work with for the rest of the questions. Okay, so we've got the two radiuses. What I'm going to do is I'm just going to roughly, well, I'll do it on here. So we've got 9.6 there, and we've got 12 there, and we want this angle here, so we'll call that theta for now. So we're going to be using the cosine rule. So are we going to use the cosine rule? Just trying to work this out. We want the angle. We are, because I've not spotted that, so we know that that's 20. So it is the cosine rule. I was kind of missing a value. Okay, so for the cosine rule, it's that a squared is equal to b squared plus c squared minus 2bc plus a. That's the cos a that we're trying to work out. So if we manipulate this a little bit, cos a is going to be equal to b squared plus c squared minus a squared divided by 2bc. Right, so so the angle that we're after is going to be equal to cos to the minus 1 of, right, I'm going to pick back up. Now I've got these values here. So 12 squared plus 9.6 squared minus 20 squared divided by 2 times by 12 times by 9.6. Right, so shift cos, and then we'll type it in just like that. 12 squared plus 9.6 squared minus 20 squared divided by 2 times 12 times 9.6. Close my bracket. What do I think would be a sensible answer? Roughly, that's the 180 bigger than 90. So anything in the region of 140-ish. Yeah, that looks fine. So we're looking at 135.3253 ... Right, suitable degree of accuracy. Doesn't tell us in the question. 3 significant figures. So I'm going to go 4 significant figures. So 135.3. Okay, question 28. Leo runs for 12 seconds. The graph shows his speed time. So the distance he runs is less than 100, is less than 67.5. So that's going to be equal to the area. Okay. 4 marks. Just trying to work out how accurate to be with this. We want the area of the curve. I'm suggesting splitting it into 3 shapes: a triangle, a trapezium, and a triangle. But we could go even more accurate and split that into it. I think I'm just going to treat it as a triangle, though. It doesn't say anything more detailed than that. So the distance he runs is less than. Okay, so the area of this is going to be half of 5 times 8. So that's going to be 40, so that's going to be 20. The area of this one is going to be a half of 8 plus 9 times by 4. So that's going to be 34. So let me just double check that in my head. 17 times 2, 34. Then this is the one that I'm slightly debating whether to split it into two shapes, but we'll stick with it as it is. So the area of this one is going to be equal to 9 times 3, which is a half of 12. Which is 6. So I've done that one wrong. 9 times 3 is, I added them. I was getting confused with this. Half of 27, which is going to be 13.5. Right, that's better. Right, so total area, so distance must be less than these three added together, because actually we've gone for slightly greater. So it must be less than 20 plus 34 plus 13.5. So the distance must be less than 20 plus 34 plus 13.5 must be less than, perfect, 67.5. So the distance must be less than 67.5, which is what we're asked to show. Okay, part B, work out the average acceleration for the first 9 seconds. State the unit of your answer. So the acceleration is going to be the gradient of the line. The first 9 seconds, we want the average. So we want to do the gradient of the line for the average acceleration. It doesn't ask at a specific point, so that's going to be 9 divided by 9. And we can get our unit from the graph. So we've done meters per second divided by time in seconds. So that's meters per second squared. 1 meter per second squared. Right, and that brings us to the end of the paper. Okay, and again, I'll bring this up one more time. So we've got the topics for each of the questions, and we've got the mean mark achieved by each grade. So that gives you rough grade boundaries for this paper alone. So I hope you find that useful. Please do any questions, comments, or feedback. Please add them to the add it as a comment to the video, and I'll get back to you fairly quickly. Thank you very much for your time in listening. I hope you find it useful. And again, subscribe if you like.